Hi and welcome to maths class. This is a short video to talk about mutually exclusive events in probability. So mutually exclusive means that they both can't happen at the same time. So if event A and event B are mutually exclusive, then they can't both be an outcome of a trial. So a really simple example is when I flip a coin, I can either get heads or I can't get tails. I can't get heads and tails because they're mutually exclusive, okay? So here's another example. If I roll a die, set A is getting a multiple of 3. I get the number 3 or I get the 6. Set B is getting the number 2. This is what it looks like on a Venn diagram. Sorry, it's a bit small there. So set A, you can see, has 3 and 6, and set B has 2 in it, and then 1, 5, and 4 are on the outside. Now, what you need to notice here is that there's no intersection. Normally when we draw a Venn diagram, our sets overlap and there's that special section where both things happen. There is no overlap for mutually exclusive events. So if there's no overlap, then that means the probability of the intersection is 0. Remember that intersect, we use the word and. So the probability of getting A and B equals 0. And therefore also the union, which is OR, has a special way of being calculated. If I look for the union of A and B, it's going to be this set here plus this set here, which means the probability of the union is the probability of A plus the probability of B. Just one other word for you. The word disjoint, when referring to sets, means that they're not joined, okay? Disjoint sets have no elements in common, so it means that they are also mutually exclusive, but we'll use the word mutually exclusive most often. Now, just for comparison, here's an example of two sets that are not mutually exclusive. A is the set of even numbers and B is the set of multiples of 3. So A and B have an intersecting area here, and the probability of the intersection is not 0. In fact, the probability of the intersection is 1/6, because the intersection is the number 6. It happens in both sets. So if I roll my die and I get a 6, then both A and B have happened. The probability of the union is the probability of A, that's this circle here, plus the probability of B, that's this circle here. And then I've counted this intersecting part twice, so I subtract the intersection because I only want to count it once. So I get a half plus a third minus 1/6, which is 3/6 plus 2/6 minus 1/6, which gives me 4/6, which is 2/3. Now, if I think about that, what I'm counting here is the probability of getting either a 2, a 4, a 6, or a 3. That's the union, and that is 4 numbers out of 6, which is 2/3. So, just to recap, mutually exclusive events can't both happen at the same time, and we have these two important rules. The probability of the intersection is 0, and the probability of the union is the probability of A added to the probability of B.